molar concentration of a solution is the number of moles of solute per liter of solution. It is a quantity widely used in chemistry because it simplifies calculations. We calculate molar concentration using the formula C equals N over V, where C represents the concentration in moles per liter, N represents the number of moles of solute, and V represents the volume of the solution in liters. This concentration can also be expressed in molar, represented by the capital letter M. Moles per liter and molar are two ways of expressing the same unit. Let's do an example. We're looking for the molar concentration of 250 milliliters of a solution made by dissolving 0.2 moles of NaCl, or sodium chloride, in water. First, we identify the values given in the problem. The number of moles of solute is 0.2 moles, and the volume of the solution is 250 milliliters. To find the concentration in moles per liter, we must convert milliliters to liters. 250 milliliters is equal to 0.250 liters. Next, we can replace the variables in the formula with the given values and calculate the answer. C is equal to 0.2 moles divided by 0.250 liters. The molar concentration is equal to 0.8 moles per liter, or 0.8 molar. Let's solve another example. We're looking for the molar concentration of 0.7 liters of a solution obtained by dissolving 80 grams of NaCl in water. First, let's identify the given values. The 80 grams of NaCl is the mass of the solute, and 0.7 liters is the volume of the solution. We are looking for the molar concentration. The number of moles of NaCl is not given directly in this problem. We can calculate it from its molar mass. To find the molar mass of NaCl, determine the molar mass of sodium, Na, and chlorine, Cl, using the periodic table. Sodium has a molar mass of 22.99 grams per mole, and chlorine has a molar mass of 35.45 grams per mole. To find the molar mass of NaCl, add up the molar masses of each atom in the compound. The molar mass of NaCl is therefore 58.44 grams per mole. Next, we can find the number of moles of NaCl using the formula large M is equal to small m over N, where large M represents the molar mass in grams per mole, small m represents the mass in grams, and N represents the number of moles. We substitute the values into the formula. We determine 58.44 grams per mole is equal to 80 grams divided by N. Then we isolate N. And we obtain 1.37 moles. Let's return to the original problem, where we had a mass of 80 grams of NaCl and a solution volume of 0.7 liters. We now know the number of moles of NaCl, which is 1.37 moles. We have all the information required to find the molar concentration. Replace the variables in the formula with the given values. C is equal to 1.37 moles divided by 0.7 liters. We calculate and obtain a molar concentration of 1.96 moles per liter. Sometimes the molar concentration is given in the problem, but the volume of the solution, the number of moles of solute, or the mass of the solute is unknown. Use the same formulas and make sure to isolate the correct variable.